The question that I have is, could you do an example on finding the moment of a single force by the scalar method? Let's go over a worked example from the book. And this problem involves several different cases, and we are to find the moment about point O for each of these cases. Here's one case, and we need to find the moment about point O for this force 100 Newton that is acting at the end of this cantilever beam perpendicular to it. And we see this for this problem that the line of action is this vertical line, and the distance perpendicular to the line of action is therefore 2 meters, right? According to a sign convention, the axis that comes out of the paper is our positive axis of the moment. If I were to use the right-hand rule to figure out the direction of the moment of this force, we'll be holding our fingers in the direction of the force. That will be this one right there. And then you will see that the thumb is going to be pointing in the direction opposite to the axis of the moment. And therefore we have a negative moment. The magnitude of the moment is force multiplied by the distance perpendicular to the line of action, which is 2 meters, and therefore we have minus 200 Newton meter as the moment about point O for this force in accordance with our sign convention. And here is our second case, and in this case, just as in the first case, your thumb is still going to be opposite to the axis of the positive moment using the right hand rule. And in this case, we also want to be careful in figuring out the perpendicular distance, little d. So this is the direction of the force, right? So we want to extend that, and that becomes your line of action of the force, right? And then we are interested in the moment about point O. So now we want to draw a perpendicular to the line of action of the force, and therefore this is your little d. And this, of course, from geometry we see is exactly equal to this distance, which is 0.75 meters. And therefore, moment about point O for us is minus 50 Newton multiplied by 0.75 meter, which is minus 37.5 Newton meter. Here's our third case, and just as in the first two cases, we have a clockwise moment, and therefore the moment is negative. The line of action of the force is this, and therefore we need this distance, right? This is the perpendicular distance to the line of action of the force, and this part is not given, and therefore we're going to have to figure that out. So you can see that's 2 cosine 30, right? 2 cosine 30, and therefore the total distance will be 4 plus 2 cosine 30. So MO equals minus 40 pounds multiplied by 4 plus 2 cosine 30 feet, and that gives you minus 229 pound-foot for the moment about point O. And here is our fourth case, and in this case, the thumb and the axis of the positive moment coincide, and therefore we have a counterclockwise moment. All right, and this is the line of action of the force, and therefore the distance perpendicular to that from point O would be this distance right there, right? And therefore this distance, and this is not given just like the earlier problem, so we're going to have to figure that out. So this is 1 foot, and this is 45 degrees, and therefore this distance is 1 sine 45. So a moment about point O is 60 pound multiplied by 1 sine 45 foot, which is 42.4 pound-foot. And note that we have a positive moment this time. And here's our final case. Once again, our thumb and the axis of the positive moment coincide with each other, and therefore we have a counterclockwise moment or a positive moment. And this is our line of action of the force, and therefore the distance perpendicular to that would be this little d. And we're just going to have to subtract 1 from 4 in order to get this distance. And that's what I have done over here. So MO equals 7 kilonewton multiplied by 4 minus 1 meter, which is 21 kilonewton meter. Once again, we have a positive moment. In all of these cases, I use the right-hand rule, right, to figure out the direction of the moment, right? But if you're more comfortable with the wrench method, you could use that method. And this slide illustrates how you would place the wrench in order to figure out the direction of the moment. Just make sure that your range is perpendicular to the line of action of the force. So here it's this, and here it should be placed like that because that's the line of action of the force. And here's the line of action of the force, so the range should be perpendicular to that. Here's the line of action of the force, and therefore the range should be perpendicular to that. And of course, you come to the same conclusion about the direction of the moment. So here you have a clockwise moment. In other words, nut placed at point O is going to be rotating in the clockwise direction. Nut placed at point O is going to be rotating in the clockwise direction for case B. Case C is the same. Case D is going to rotate in the counterclockwise direction. And case E is going to rotate in the counterclockwise direction. And remember, our sign convention is that counterclock is positive and clock is negative.